to Bhanzu classes. So I hope all of you are doing wonderful and are super duper excited to start a new chapter with me called as Rational Numbers. So we are going to begin with a very interesting chapter today, and what are we going to cover is Introduction to Rational Numbers. So what will be in its introduction? Let's have a look at the topics which we are going to talk about. We'll be talking about numerator and denominator, and also what are equivalent rational numbers. So I hope all of you are excited for this, that what are actually rational numbers. Till now we have talked about different types of numbers like natural numbers. What are they? They start from 1, goes on till infinity, and they are also called counting numbers. Then we had talked about whole numbers. When you add 0 to the natural numbers, they become whole numbers. And if you have negative numbers, 0 and other positive numbers also, then we call them integers. And then if you have part of a number, that is called fractions. So till here everybody has learned till now, right? But what if you have negative fractions? That is where comes rational numbers into picture. So rational numbers are positive fractions also and negative fractions also. But when you talk about only fractions, they are always and always carrying a positive sign with it, right? So let's recall. Natural numbers are also called counting numbers. Starts from 1, goes on till infinity. Whenever you add 0 to natural numbers, right? 0 and natural numbers, then they are called whole numbers, right? Then if you have negative numbers, 0 and positive numbers, that is what is called integers. Fractions, part of a number. And when you have negative fractions and positive fractions, that is what is called rational numbers. So how do we represent a rational number? A rational number is defined as P by Q, where P and Q are integers, but Q, that is, the denominator, is never equal to 0. So what can we write the rational numbers as? Can we write few examples? Yes, like 2 upon 3, where 2 and 3 both are integers. Minus 5 upon 7. Yes, it's a rational number. 0 upon 9. Yes, it's a rational number. But if I write 9 upon 0, that's not a rational number. So like this, you can write so many rational numbers, where P and Q should always be integers and Q should not be equal to 0. This is what is the condition for writing rational numbers, right? So let's move ahead and see, are all fractions rational number? What are fractions? They are the ones with positive signs. Yes, they can be rational numbers, but all rational numbers are not fractions. That is, vice versa is not true. Because rational numbers are negative also, but you cannot say a negative rational number as a fraction, right? So that's why we say that vice versa is not true. And also, the decimal numbers can be written as an ordinary fraction, and hence they are also called rational numbers. Let's see few examples to it. Like for the first one, they say all fractions are rational numbers. Yes, let's write 2 upon 3, 7 upon 9, 11 upon 19. All of these are rational numbers also. But if I write a rational number as minus 7 by 9, that's not a fraction. Right? So vice versa not true. And in the second point, decimal numbers like 3.5. Is it a rational number? Yes. You can remove the decimal, write upon 10, and then you can simplify it with the table of 5. It is having the common factor. You get 7 by 2. So this is also a rational number. So decimal numbers can be written as an ordinary fraction, and therefore they are called rational numbers. Because anyways you are converting them as fractions. Right? So this is how we talk about, are fractions rational numbers or not? Yes, they are. Right? So let's move ahead and solve a question. Interesting one. Is the number 2 upon minus 3 rational? What do you think? Just now we discussed the definition of rational numbers, that rational numbers are the ones which are written in the form of P by Q, where Q cannot be equal to 0 and P and Q are always and always integers. So yes, 2 is an integer, minus 3 is also an integer. So what happens? Is it a rational number? Yes, it is, but there is a trick in this. There is something interesting to find it out, that minus can never be in the denominator while writing rational numbers. So where do we shift the minus to? We will be shifting the minus sign to the numerator. So now you can say that minus 2 by 3 is a rational number. What is it? That's a rational number. So this is also called one of the steps of standard form of writing rational number, which we will be discussing later in our sessions. So rational number cannot have a negative sign in the denominator at any point of time. You can shift it to the numerator, and that is when we can call it as a rational number. Clear, everybody? Let's move ahead and see that P is the numerator as we discussed and Q is the denominator in the rational number, where both of them can be integers, right? But Q should never be equal to 0. So any integer can be expressed as a rational number. For example, 5, minus 3, 0 and so on, right? Because we can write them as upon 1. Thus, rational numbers include integers and fractions, which we were discussing in the beginning of the session, that how come the big round of rational numbers has in it natural numbers, whole numbers, integers and fractions. What was the reason behind that diagram? This was the reason. We are discussing each of them separately, right? That all fractions are rational numbers, all decimal numbers are rational numbers. Now all integers are also rational numbers, right? You can write 5 as 5 upon 1, which will become a rational number. Minus 3 is minus 3 upon 1, which is a rational number. 0 is 0 upon 1, which is a rational number, right? So that's why they include integers and fractions both. Moving ahead, what are equivalent rational numbers? So what does the term equivalent suggest? Equivalent says equal in it. Now what can be equal? If the numerator and denominator of a rational number are either multiplied or divided by a non-zero integer. Non-zero integer, very important. We get a rational number, a new rational number, which can be called as equivalent to the given rational number. Which can be called as equivalent to the given rational number. Got it? Like suppose if we have minus 2 upon 3 as the given rational number, we want to find it out its equivalent rational number. So either you can multiply it by the same rational number or you can also divide it, right? So here we are doing multiplication. So minus 4 upon 6. So the new rational number which we got is one of the equivalent rational numbers to the given rational number. You can find n number of equivalent rational numbers. Keep multiplying it by any integer, a negative or a positive. You will be getting a new fraction, a new rational number, which is the equivalent rational number to the given rational number. Let's see examples like minus 2 upon 3, 2 into 2, minus 4 by 6. Now if you have to see the division example, 12 upon minus 15 divided by 3 will give you 4 upon minus 5. But because it's a rational number, you should write it as minus 4 by 5. Because rational numbers never carry the minus sign in the denominator. It is always taken in the numerator. So either you can divide them or multiply them by the non-zero integer to get the equivalent rational number. Any number you can choose of your favorite number, right? You can choose 10. So minus 2 upon 3 into 10 by 10 would give you minus 20 upon 30. That is also one of the equivalent fractions of it, right? Over here you can also take the example minus 12 by 16. They will be having a common factor of 4. Divide them by 4, right? You will get minus 3 by 4 over there. That is also the equivalent rational number, right? So you can choose any number for multiplication or division, the same non-zero integer. So this is how we find the equivalent rational numbers to a given rational number. Now as we were discussing, did you know about 2 upon minus 7 is actually minus 2 by 7, right? Minus 10 by 3 is also minus 10 as by 3. So minus sign can be taken as common like this also, but it will never be only in the denominator. It can be only with the numerator or like this between the numerator and the denominator. Right? Let's move ahead and see and solve a question over here. So we are given a question for equivalent rational numbers. The rational number is 5 by 4. This is the given rational number. Now they are saying by what number will you multiply or divide that your denominator becomes 16. Now think over to it. How can you make 4 as 16? By? Yes, multiplying by 4. So we discussed, if you are multiplying either the numerator or denominator by one of the non-zero integers, you have to multiply the numerator also or the denominator by the same non-zero integer. So 5 into 4 is 20. Right? Now for the next one, if we see 5 has become 25. How? Multiplying by 5. So how will I get the second denominator now? 4 into 5, which is 20 again. Are you all getting it? Yes? Let's see the last one. How will we make 5 as minus 15? Multiply by minus 3. Now, the denominator also to be multiplied by minus 3. So, 4 into minus 3 is minus 12. So, this is how you can fill in the blanks by the concept of equivalent rational numbers. Right? What are we doing? We are multiplying or dividing by the same non-zero integer. Let's try the second one. How can you make 7 as 14? Multiply by 2, right? So minus 3 into 2 would be minus 6. Now let's see the second one. We have 9 in the numerator. So minus 3, how can it become 9? Multiply by minus 3. So minus 3 into minus 3 would give you plus 9. So 7 into minus 3 would give you minus 21. And the last one which says that your numerator should be minus 12. So minus 3 can be made as minus 12 into minus 4 into plus 4. Right? Because it should be a negative sign. So minus into plus is minus. So now 7 into plus 4 is 28. So this is how we get our answers for equivalent rational numbers. You have to see by which same non-zero integer either we should multiply or divide according to the given one of the numerators or denominators. Right? So keep practicing more questions like this for equivalent rational numbers and you will be thorough with the topic. So now let's summarize what all we had discussed in the session today. We had talked about numerator and denominator, which are called P and Q in case of a rational number where Q can never be equal to 0. And the last one we talked about equivalent rational numbers, where you multiply or divide the given rational number by the same non-zero integer to get one of the equivalent rational numbers for it. And for one of the rational numbers, there can be infinite equivalent rational numbers because we have infinite numbers. So you can either keep on multiplying it by any of the numbers or divide it. So keep practicing and keep exploring like this till we meet next. Have a happy learning and spark your curiosity. Bye-bye.